Hello everyone, welcome back to the Aspen Tech channel. And today we are bringing the next lecture, which is related to the optimization using Aspen. As we know that optimization is one of the key parameters whenever we talk about the operation in the industry, and accordingly optimization has always played a key role because we are always in search of finding the most optimized or best operational parameters whenever we talk about the optimization. So accordingly we are bringing this lecture once we will be doing the optimization using Aspen Plus in our today's video. So in today's lecture, our focus is to do the optimization, and for this we have selected the benzene toluene mixture, which needs to be separated using a flash separator. The vapor fraction of the mixture is 0.5. The pressure is 5 bar, molar flow rate of 1000 kg mole per hour, and it is an equimolar mixture, means the mole fraction of benzene and toluene are same in the process, and the objective is to do the optimization to obtain 65 mole percent benzene in the top product, and we will be using the optimization tool to proceed that case in Aspen Plus. So we will go to the now to the Aspen Plus and simulate this process and see. First we will simulate the flash separator, and then we will be using the optimization tool to carry out the optimization in Aspen Plus. So we will first add the components benzene and toluene, then we will select the property package as SRK and steam NBS as the free water method, and then we will click on the run, and once results are available we will go to the simulation environment. And once going to the simulation environment, we will select the flash to separator block from the model plate, and we will do the connections of feed, top product and bottom product, and then we will specify the feed, which is vapor fraction as zero point 0.5, pressure of 5 bar, mole flow rate as 1000 kg mole per hour, and mole fraction of benzene and toluene as zero point 0.5 zero point 0.5 each. After that, click on next, and then we will go to this block. Obviously we do not provide it with the temperature, but we are provided with the pressure, that there is no pressure drops with 5 bar. And if you remember that 0 bar means inlet pressure is equal to outlet pressure, and there is no pressure drop in the system. So either we specify it as 5 bar or we specify it as 0 bar, it is same. Similarly, if there is a pressure drop, then we will specify minus zero point 0.1, minus zero point 0.2, or inlet minus outlet pressure. We can simply specify the pressure over here. And now we are not given the temperature value, we are given the vapor fraction in the feed. So by default we will take the value over here of vapor fraction as zero point 0.5, and after that we will click on the run, and once results are available we will select the stream results to see the conditions which we have got. If you go to the mole fraction, you can see that 58.45% benzene is obtained in this process, while we need 65 mole percent benzene in the process. So what we need to do, we need to carry out the optimization process to get the required specification in the system. So going down, and in model analysis tool, after sensitivity analysis, obviously we have performed sensitivity analysis previously, we will click on this optimization to get the optimization process. So what you need to do, click on this optimization, click on new O1. It's up to you if you want to keep this nomenclature. Then first we need to define the variable, and obviously the variable is the mole fraction of benzene in the top product. So click on this new and name it as benzene. Then in type we will select as mole fraction of S2, and component is benzene. And then in the objectives and constraint, we will specify the objective, which is to maximize the benzene, and optimization is active. And in maximize or minimize, obviously the same variable name should be entered as have been defined. Obviously we want to maximize the production, we want to minimize the operational cost, we want to maximize the revenue, we want to minimize the energy consumption. So it's up to you whatever case you has been given once you are doing the optimization process in the system. So what we need to do, we will click it and we will name it the same benzene. Even the spelling should be same, if it is capital it should be same, so benzene. And then there is a constraint. Obviously always optimization comes with the constraint, and our case the constraint is 65 mole percent benzene. but we will first solve it without any constraint in the system, like the, you can say, the boundary that we do not want to get above it in the system. And now we need to vary some variable to get the result. So click, and obviously it's a block variable b1, and we will select the vapor fraction because that is the only variable by varying pressure. Obviously the chances will become, so v frac lower bound zero point 0.1, upper bound 0.5. Click on this run button and you see results are now available, and you go to the results, you can see 64.6% benzene is obtained in the system. Earlier the number was 58.46%, and now the number is has bit up improved from 58.46 to 64.6%, but our requirement is 65 mole percent benzene in the system. So, and the manipulated variable has been changed from zero point 0.5 to zero point 0.1. Now you can see that at zero point 0.5 we got 58.45% and zero point 0.1 we got this. So now we will specify the constraint, click on this new and specify. Again we will do the same way, that in this case 65 mole percent benzene is our constraint in the process. So again it's about the nomenclature, C1 benzene, and the mole fraction of benzene in the top product, which is S2. And then in the spec, obviously there are three specification: equal to, less than equal to, greater than, or equal to. So we will specify only equal to. In the first tab we will specify the specification, which is 0.65 in our case, then the variable which is defined benzene, then the tolerance 0.0001. Obviously the tolerance effect has been already explained in our previous video as well. So now reset it and run it, and you see results are now available, but you see that constraint was not defined in the optimization. The value is still the same. Constraint defining doesn't mean that it is incorporated in the optimization. Obviously you have to go to the input, and in objectives and constraint you have to specify it. So what we need to do, we need to go to this objective and constraint and select this constraint, and then we will reset it and run it so that all the iterations are included, and you see you are getting the error. Now the error is because if you see at the upper bound, which was zero point 0.5 vapor fraction, we got 58.46%. The lower bound, which is zero point 0.1, we got 64.66 more percent. It means that the result is not available in this bound. So what we need to do, we need to go to this vary, and we need to change this manipulated variable as 0.01. We need to change the bound type, and once we run it, the results now will be available. And as you can see, results are now available, and the reason was same, that you have specified the wrong bounds. If that constraint was 63%, you would have got your required answer, but now that constraint was 65%, which is outside these bounds. So obviously different types of errors have come, that the value is not calculated and up to so on. But the main reason was that in this process, because of specifying the lower value of bound as incorrect, and now you can see in results 0.65 or 65 mole percent benzene is obtained. Previous value was zero point 0.1, and now its value is 0.07293 vapor fraction that has been obtained in this process as a result of optimization in the system. Also you can see the iterations over here, the four iterations and the constraint. The error of 3.42 multiplied by 10 raised to power minus 5, which is small, and the status is converged. So that's it from this lecture. Thank you so much. Please do watch, like, share the video, and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.